Okay, this is part 2 of 11.1. So a sequence is said to have a limit if, in the usual sense, the same way as if a function had a limit, which means if for all epsilon greater than 0, there exists some capital N such that all remaining terms after that point live within the epsilon. So for example, let's say this happens to be the epsilon I pick. So I can go plus or minus this far from the limit, and I'm happy with that. Maybe that means, 4 decimals after, so 4 places after the decimal or something. Whatever my epsilon is, and that's my tolerance, then there's going to be some point, and in this diagram, that would be over here. That means all the terms forward of this line have to live within the tolerance I've specified. And you have a homework with those questions similar to that in them. So for example, if this is my epsilon right here, plus or minus epsilon from this limit, then this would be where capital N is, and everything in the future from everything forward of that line has to be good. Okay? So that's what that's saying. So terms can go above or below the limit, but there's this shrinking neighborhood around the limit where the terms have to live. Alright, so some obvious facts. You would just do this naturally, but it looks really weird sitting there in calculus terminology. If you have one sequence and it's going to 1, and a different sequence and it's going to 2, then you can add these guys up term by term. And so if one's going to 1 and one's going to 2, then the sum has to be going to 3. It just seems obvious, and it is obvious. And all you have to do is, with these neighborhoods, you just have to say, well, if I have a tolerance of, say, 1/1000th, what you end up saying is you say, well, I'm going to give, 1/2000 is the tolerance on the A ends, and 1/2000 is the tolerance on the B ends, and then you just pick whichever one is more conservative, so like the higher of the two usually, and then you just it works for both of them. So this is not a problem. So you just have to kind of share the tolerance and squeeze down until you get the desired tolerance. So this all works. This one says if the thing is going to, let's say 7, if the terms in your sequence are going to 7, but you change your mind and decide to raise everything to the power of p, maybe p is 2, then actually you're going to be going to 49. That's pretty obvious. But anyway, that's what that's saying. And that's saying that if let's say if the limit, let me write it this way, if the limit of the a ends is going to 7, then you can just take that limit and then square it, as opposed to squaring each and every term and saying, well, the terms are going to 49. Well, duh. If the original sequence was going to 7, then the new sequence has to go to 49. And I think you would do that naturally, so I shouldn't really stress that too much, because it's normal for you to do that. Okay, squeeze theorem. If you have 2 sequences that are going to the same place, and there's one where term by term the terms are sandwiched between the other 2 terms, then they all have to go to the same place. So let me use an obvious example. I'm going to just recycle the same example I keep using. Let's see, 1/2, 1/4, 1/8, 1/16, 32nd. Maybe these are the A's. And then these guys are over here, maybe, oh gosh, I don't know, like 1/3, 1/5, 1/9, 1/17, 1/33. And these guys are both going to 0. And then the B's in the middle, maybe they're sandwiched in between, right? So it's 1/2.5, right? Could be in the middle. It's kind of very silly sequence here. Okay, then these guys have to also be going to 0. Because if the A's are going to 0 and the C's are going to 0, that forces the B's to go to 0. That's all it's saying. Okay? But it doesn't have to be going to 0. It could be going to somewhere else. That's fine. Okay, now this guy is saying if the magnitudes are going to 0, then the thing itself has to be going to 0. And this works in any dimension. So let's say maybe the direction keeps bouncing around, like the angle, for like, you can think about this in 2 dimensions. The points are coming in closer and closer and closer to the origin, but they're spinning around. Okay. What it's saying is it doesn't actually matter if it's spinning around where it's going. If the magnitudes of these vectors are going to 0, then the whole thing has to be going to 0. So that's what that's saying. Okay. Next, we have L'Hopital's rule for limits. All this is if you have, if you want to know where something's going and you don't know, you know, which is stronger, natural log or n. So you know this is, this is infinity and this is infinity. So who's going to win? Because if you have 2 infinities, you can stack them so that it goes anywhere you want, actually. It can go to positive infinity, it can go to 0, it can go to 3, you know? Right, because if I said 3x over x limit as x goes to infinity, that would be 3, right? So you don't know what it is. Infinity over infinity is one of these weird things. So if you don't know where it's going, L'Hopital's rule, this should be fine. Should help you. Okay. For what values of R does this guy converge? This is your P series. I think we said that was page 717 in the textbook, something like that, in that vicinity. But look up P series in the index and then go to the page it tells you to. So we know that 1 squared, 1 cubed, 1 to the 4th, all that stuff, that converges to 1. So that's good. So that's fine. I should fill this guy in, right? It's good over here. But it's not good if R is -1 because it goes plus minus, plus minus, plus minus, plus minus. But all the points in between, like a half, a quarter, you raise them up to a power, they go to 0. Okay? But if you're just beyond that just a teeny bit, like over here, 1.1, and you raise it up to a higher and higher power, it's going to go to infinity. So you should just know the P series automatically, this is what's happening with the P series. Okay? And here's just an example. This reminds me of one of your homework questions. We want to know if this guy increases or decreases, and you can go through this if you want. This is algebra. Or you can skip this. I just want to show you. You can use algebra. This is the thing itself, and then here is where you chuck n plus 1 in for n, and then you just work this thing out and do the algebra, and it says, yeah, as long as n is greater than 1, we're good to go, right? So you can go ahead and use algebra and compare 2 consecutive terms, and you see that the second term is always smaller than the first term, okay? But you could just use calculus because this guy is a function. So what we're going to do is we're going to take the continuous form of this function and we're going to take the derivative, set it equal to 0, and we find that this function, is decreasing, increasing, and decreasing. But the important part is from 1 onward, it's decreasing. So who cares what it's doing everywhere else? I mean, the only thing you need to check is if you're one of these people like me who likes to start your sequence with n equals 0, you just have to test the first couple terms to see what's going on. See, is 0 to 1, is it going up or going down? That's all you need to know. But then you know that once you hit 1, everything else is downward. Okay?